Hello, everybody hear me? Perfect. My name is Spencer Gibb. We're going to talk a little bit today about API gateways. I got the name for this presentation. I watched Brendan Burns talk about virtual machines. Anyway, so let's get right into it. My name is Spencer Gibb. I work for Pivotal. I work on the Spring team. There have been a few of us here at the conference today. I've been working on Spring Cloud specifically for three and a half years now. We also do Cloud Foundry at Pivotal. So let's talk a little bit about what is an API gateway. Chris Richardson has a great definition at microservices.io, but in essence, it's something that lives in front of your microservices architecture. It's the public facade. It is the single entry point for your clients, whether those are server-side MVC app or a single-page JavaScript application or a mobile app, right? They would all go through an API gateway. And you have all these microservices deployed behind an API gateway, and it knows how to connect to each one and all the instances that are deployed behind it. API gateways has lots of different responsibilities and can do different things depending on your application's needs. The most basic thing it does is routing, right? Hey, I want to go to the user service and send it there. They can be used for resiliency. You know, if you have failures in a particular zone or region or with a particular application, it can route around those problems. Another common use case is strangling a monolith, right? You've got an old, I don't like the term legacy. Someone else coined the term a heritage application, right? This is the thing that's making your company money, right? Not your API gateway. So it's the thing, but it's old and you want to make it new and use new patterns. And so you build the new functionality and you put it off to the side as microservices. And when the application asks for the new piece, it routes to the new one, and otherwise it sends requests back to the old heritage application. Security can happen here, monitoring, surgical routing. I know lots of places will say, hey, we've got a problem with this particular customer. Let's route him to a debug cluster or something like that, where you've got instrumentation turned on and extra logging turned on so you can see what's happening, what problems are happening. In general flexibility, right? Your front-end application doesn't have to change if your back-end changes. You can just simply change your routing rules, for example. There are lots of different things that can be called an API gateway. We'll talk a little bit about each one, but we're going to talk about a specific category that we'll get to. There are appliances that could be considered an API gateway, right? Hardware or virtual. These things are typically a black box, pretty low level, and not really super flexible. There are SaaS gateways that are generally API driven. Again, a black box. They have their different methods of charging for their use. Many times this is the new ESB in companies, right? This is where companies will try and enforce rules, and many times this causes headaches for developers because now they need to open a ticket to get a fix rather than writing some new code and having it deployed. There's the venerable web server. This could be, generally it's open source, Apache, HTTP server, Nginx. Sometimes these can be programmed. Sometimes it's in C, you write a C module, or maybe Lua or something like that. So lots of times this is perfectly acceptable and might fit your needs. There's a new category that I added this slide in, is the mesh router. So this is products like Linkerd or Envoy from Lyft, and these routing tools sit as sidecars next to your applications. The category that we're going to talk about today is kind of a developer-oriented API gateway. So rather than tickets or C modules or Lua, this is something that an enterprise could use and use Kotlin or Java or a language that they're familiar with. And so no tickets, just a new deployment for changes. And it's part of the infrastructure, right? DevOps, developers maintain this thing. So let's start back at the beginning. This is a fantastic talk by the Netflix Edge lead, Mikey Cohen, that he describes the history of edge routing at Netflix and why they ended up building their own. They used to use one of the SaaS gateways, but it just didn't fit their needs. So they wrote their own. And Zuul 1 is servlet-based, so there's a Zuul servlet. So necessarily it uses blocking APIs from the old servlet APIs. And when I started Spring Cloud, myself and Dave Sire, integrating Zuul 1 caused many, many headaches and lots of keyboard mashing and curses and all sorts of stuff. The API is a bit clunky and unwieldy, but it served its purpose as well. We have customers that front fairly large applications with Zuul 1 and are doing fairly well with it. So last year, Netflix wrote a blog post about Zuul 2, and we've had questions regularly since then when Zuul 2 will be integrated into Spring Cloud. And the answer has been, for a long time, it was I don't know, because they have never released it. A few weeks ago, one of the engineers did talk about Zuul 2, and so there have been some updates, but it's still, I think they hope to have it open sourced either by the end of this year or the beginning of next year. And we needed something. Who was in Stefan's talk about Reactor and Flex, WebFlex? So we needed something that would work with those technologies and provide solutions to some of the problems that exist in Zuul. So Zuul 2 is not going to be backwards compatible with Zuul 1. It has different APIs. It was originally written with RxNetty, which is an abstraction for Netty written in RxJava. But that project is essentially abandoned, so they have rewritten it just to use the Netty primitives. And there's quite a bit of overlap between a lot of the things that are in Zuul versus the things that are found in Spring Framework. So earlier this year, we decided to to roll our own. So in comes Spring Cloud Gateway. So the foundations of the gateway are important and provide some interesting things. So it's based on Spring 5, which levels to Java 8. So that's a good thing. We get to use a more modern version of Java in the Spring projects, which is fun. It's built on Project Reactor, right? So this is, I'll show a little bit about that, but it provides non-blocking functionality that we're able to take advantage of so that we can support long-lived connections like WebSockets. And it's also built on Spring Boot 2. So the gateway can be auto-configured for you and provide metrics and actuator endpoints to configure and display information about the gateway. So Project Reactor. This provides us with non-blocking I/O. It also allows us to react to back pressure, right? The client can say, or the server can say to the client, hey, I only have this many available. And this is one of the projects that is sponsored by Pivotal. So this is I redrew this picture from one of those presentations given by the Netflix engineers, but this is essentially what the event loop looks like, right? A request comes in, gets put in the queue, and then there's a single event loop. Now in the case of Netty versus something like Node.js, the JVM will have multiple event loops, right? One for each thread available on the hardware. But in essence, there's just the one event loop, and then we make calls out on the back end, and then it's callback based. So there's nothing blocking. So we had have a colleague that did some benchmarking for Spring Framework, and he was comparing Spring MVC, its load capabilities versus WebFlex. And he found that as the number of concurrent connections was higher, the Netty-based, the WebFlex-based stack handled those connections much, much better than Spring MVC. Obviously, right, as you create more and more threads, you won't be able to handle as much throughput. So I was very interested in that body of work because now I want something to benchmark the gateway. So he was able to plug in the gateway and get the similar numbers and start to show very little overhead when going through the gateway. But we have to be careful because it's very easy for a blocking call to get snuck in here. In fact, I had an issue opened a week or two ago by someone trying it out, and they were doing some benchmarking of their own, and they said, hey, you got blocking problems. I was like, oh no, what was it? It was a log statement, right? By default, logging is blocking. It's not something you think about too terribly often, but if you don't have the right configuration, even with asynchronous logging, you could still have some issues, but those issues would be dropping logs as opposed to not blocking or blocking on the logs, right? So those are some things you'll have to watch for when you build WebFlex type applications. So Spring WebFlex, this is the alternative web stack to Spring MVC. And we were able to take advantage of lots of the internal pieces from Spring Framework to build the gateway. Things like the handler mapping. Handler mapping is where we match, does this request go to this particular controller? Web filters, predicates, right? How do you define what is a match? And I'll show you some of these things, but the server web exchange is the kind of object that you interact with instead of HTTP servlet request and response, right? So this is how you get at the request and response. And then we also are able to use Spring's path matching, which is really, really handy. So let's get into some of the internals, and I'll get to some demos here in a little bit too. So one of the things that we're really known for are our long class names, right, in Spring, but they're very deliberate and try and describe exactly what it is. So this is the route predicate handler mapping. This is the thing that says, plugs into the Spring framework and says, does this request match a gateway route? One of the differences between the Spring Cloud Gateway and Zuul is that predicates are scoped to a specific route. In Zuul, there was some disconnects because it wasn't built into Spring. And we can load these predicates and configuration from Spring Boot's config files or from a repository. I'll focus today on the Java Fluent interface, which is a really nice, simple way to define routes. Defining a predicate is super simple. These are examples of a few of the predicates that we have available. You can match off of the path or the host or a header. Basically anything that you can get at in the request, you can match on. And they're super simple and super short. And so it makes it easy if you want to add your own. I need to rename this because that class name has changed. This is what happens when you write a presentation and then do some refactoring. This isn't part of the IDE, it didn't get renamed. Anyway, there's a web handler that when the filters get loaded for a specific route, they are ordered, but because they are WebFlux, the way that a handler chain works in the WebFlux interface is that they're chained together and then they're subscribed to, and so they're run. And you can define logic that runs at the beginning or after the route has, the network request has been run. So rather than having a separate set of pre-filters and post-filters, a filter can be pre or post depending on where you put the information. For example, to add a header to the outbound request is necessarily a pre-filter. But if you want to add a header to the response going back to the client, that needs to be a post filter, and so you would do that logic in a separate place. There are also the global filters. Currently, global filters this is where I implement routing filters. So and there are 3 different kinds of routing filters based on the protocol that's being handled, right? So the filters themselves, here are some examples. We can rewrite the path, right? So this is one of the most requested features on the Zuul side is, hey, I just want to rewrite the path. And it was really hard, and we've never really implemented it. And I wanted to make sure, and this is one of the first filters that I wrote. The other thing that was hard in Zuul was that things like hystrix and ribbon and routing were all tied together and couldn't be separated. If you wanted ribbon but you didn't want hystrix or something like that, it just wasn't possible. And so now things like hystrix are, you can just plug it into a particular route and say, I want this to have a circuit breaker. So some of the benefits of this, I just actually did my spiel for this slide already. There's a little bit of spaghetti code in the retry and ribbon and hystrix, so we're able to tease that out. I talked a little bit about the simplicity in writing a filter. So in this case, this filter wants to set the HTTP status for the response, right? So in this case, it needs to be run after. So you'll see that the code actually happens after the filter chain is run by using .then, which is a operator on a mono from Project Reactor. And if it was a pre-filter, you would just execute the code before the chain. So here's an example of a route defined in YAML, right? So this would be configuration-based. It's a pretty nasty predicate. It has to match, when you're doing configuration-based predicates, each one of these is ANDed to the next. So for this route to match, all 1, 2, 3, 4, is that 8? All 8 of those predicates would have to match. Okay? And I'll show you a little bit later, but if you use in the Java predicate definitions, you can then use the and or and not, so you can get a little more creative. And then here are all the filters that are applied to this given route. So this is a sample of the Java configuration. You can see that we've explicitly said and, but these could be or. So you can, the predicates are just from Java 8 predicate class. And so you can add them however you want. One of the things I'll show today is some rate limiting filter that we have. So enough code on slides. So how many people here have seen Josh Long? Do you know who Josh is? Oh, a number of you, okay. You've seen his cloud native Java presentation where he just gets on stage and codes like a madman for an hour and a half, right? He's really, really good. So I'll try and do my best Josh Long imitation today. See if we can, there we go. So to start, I'll go to Josh's second favorite place on the internet, right? His favorite place is production. This is the second place. If you have, what does he say? If you have kids, you know, start.spring.io. If you're sad, go to start.spring.io. Anyway, so this is a page which will allow us to generate a simple project. So the gateway is available in Spring Boot 2. So we're going to select the latest milestone. We're going to call this demo gateway. We're going to select, so then we select the Spring Boot starters that we want our project to have automatically. So we're going to pick our web stack. So web flux. We are going to pick the gateway. So this is a new addition as of, I think, last week. So this is, we didn't have this before. I'll put actuator on there because that's always a good thing. I'm going to do a demo of hystrix, so I'll add that. And the one of my demos needs Redis. So I'll go ahead and now add all those things. Let's generate our project. Is that okay for font size, or does it need to be a little bigger? Too big, too small. There we go. So here's our project. Let me show you the POM that was generated. So here you can see Spring Boot 2, M5, and the gateway starter, WebFlux, Hystrix, and Redis. Okay? So that's the foundations of our little application. Let's go to the actual application. So to use the Java Fluent interface, you create a bean of type route locator. And there is a helper class called routes. And you create a locator object, and then we use kind of a builder interface to define the routes that we want to use. So, before I define my first route, one of the tools that I've used extensively with not only Zool, but in building the gateway that I wanted to show you. So, if you learn nothing today, there's two things I want you to learn about these tools. The first one is HTTP bin. Has anyone heard of this? It's a fantastic website. It allows you to send requests, HTTP requests to it, and it will send you all the information that it received from the request. So for example, in a GET, it returns all of this information, and you can see, so you can send a request to it, get this response back, and write tests basically that say, hey, I should have had this header or that header or other things that should have gone out, okay? So that is what I'm going to be routing to. So I'm glad the internet is working, otherwise this would be a very boring demo. So let's go ahead and define our first route. And we're going to call this by path, since I'm going to be routing by path. So I want to create a predicate. And you can see, if you can see that, I'll go to them. A predicate is simply a Java util function predicate class. And the type is server web exchange from WebFlux, okay? So super simple to write your own, but we have a bunch of them that are predefined for us. So there is a class called route predicates, the method path, and I can just say get. So that was the method that I showed you from HTTP bin. And I want to, and you terminate a route definition by giving it the URI where you want it to go. So in this case, http bin.org. Now if I didn't do this next part, we'd get an error. I need to give it the port. And the reason is because when the gateway loads this URI, it combines the information that it received on the original request with this new information from this URI, such as the path, right? I'm not giving it a path here, but part of that is the port. And if I didn't define what port it went to, it would use the port of the service I'm running, which if they were both 80 wouldn't be a problem, but in this case it's going to be 8080, and HTTP bin doesn't listen on port 8080. So then we'll go ahead and build that route locator. I like to do a little indenting there so I can see, especially as we move on with our routes. So I'm going to go ahead and, oh, of course. Go ahead and run this. Okay, so we can see that I have Netty started on port 8080, right? And I had a question today from one of my colleagues and says, does that mean that if you're running a gateway, one of the use cases that we've found is that some applications like to have an embedded gateway where they have an application running and then they route certain things to the back end, not everything. So the question was, does that mean that to use Spring Cloud Gateway in that case, your application needs to be a WebFlex application? And currently the answer is yes. Though speaking with one of the WebFlex authors, he said, there's something we could potentially do about that, but for the time being, your app has to be WebFlex. So the gateway is running, and now let's go here. Remember I said there were two things, right? I've showed you one, that was HTTP bin, and this is my other one. That command, HTTP, is an app called HTTPy. Has anyone heard of HTTPy? If you haven't, this is the other thing, right? Curl is loved and used by it's available everywhere, but man, every time I have to use it, I'm, man, curl, what is, anyway. So this is like curl for normal people. And so I'm going to use this today, and you'll see some of the benefits of it in just a minute. So one of them is that normally you'd need to, right, localhost 8080/get, right? This works, but one too far. HTTPy is smart, and you can say, if it's localhost, we'll just assume that it's localhost if you don't give us anything but that. So, and this is the other pretty part about it. It's colored and formatted. So you can see that this went through the gateway. So let's go ahead and, so now that we have our route, let's add a filter, right? So I want to add a filter here. Again, I have a handy helper class with this. So I want to, let's see, add a request header, right? x-foo, value is bar. So when I route through this particular route, we should see HTTP bin report back that a filter, it received a header from our gateway that wasn't included in the original request. Give that a quick restart. And there's our header that we added, right? Pretty simple. Let's go ahead and do a different kind of route. We're going to call this by host. Predicate. So this particular filter takes advantage of the Spring path matching facilities, right? So I can say star.myhost.org, and I want to route to, again, to HTTP bin. So let's go ahead and give that. Oh. Yes. Quick restart. So now I want to go to a different method. Move this to the top. I want to go to headers. So this is not going to work as written, right? So I currently have one route defined by /git and one defined by the host. So this one will fail with 404, right? The gateway doesn't know how to route this. But if I add a header, which again, HTTP host, if you create a key value, depending on what separated it, in the case of colon, it will assume it's a header. So if I do that, then it will work because it went through the correct route. Okay? Moving on, I want to show you a little bit about how you can rewrite this. So we want, let's see, we want to match host. I'm going to use the host route because it's very simple for a demo to just change the host header and pick which route I want to go to. So star.rewrite. But I want to rewrite the path. Oh, and I'm going to do like we all do sometimes, and I'm not a regex master, and I want to put it in the wrong place. So I need the rewrite. There we go. I'm not a regex master, and I probably can't remember this from my head. So I will walk you through what this does. So this says match on /foo something. And I'm going to give that, these are just Java regular expressions, right? But name that something segment, right? And capture it. So we're going to capture that segment, named segment, and then make it available to rewrite, and you can use that name in the replacement, right? Just simple Java regular expressions. So go ahead and give that a restart. So now the path, if I say foo/get, for anything else it wouldn't work, but if I rewrite.org, and that's a simple get. Okay? So it rewrote the path and applied it to the outgoing requests. How am I doing for time? All right. So I talked a little bit about Hystrix before. So we're going to do a Hystrix route. Again, we're going to match. I'll just copy these. Except now we're going to match to Hystrix. But the filter is just Hystrix. So Hystrix has integration with RxJava, and which is not compatible with Webflux, but it is compatible with a project called Reactive Streams, which is simply 4 interfaces that define a few methods, but was made by a consortium of these companies that are creating these stream libraries, including Pivotal and Netflix. So both RxJava and Reactor support the reactive streams API, so we were able to use the Hystrix support for RxJava and then convert it such that it could be used by Webflux. So I just need to give this a command name. For those of you who aren't familiar with what Hystrix does, it's a circuit breaker. And one of its jobs is to, if a particular action is taking too long, it will time out. And if too many of those timeouts happen in a certain window, it will open the circuit and help relieve downstream pressure. So the default timeout is 1 second. So if I come back to our HTTP and we go to Hystrix, one of the methods provided by HTTP bin is handy. It's called delay, and you pass it the number of seconds you want it to delay. And so what we should see is that we get a gateway timeout, right? So HTTP bin received a request and said, I'm going to block for 3 seconds, right? So all your downstream apps, they don't have to be reactive even though the gateway is. So it says, I'm going to block for 3 seconds, but Hystrix said, oh, second's done, you're done, I'm going to return with a gateway timeout, okay? So you can protect any of your routes with a circuit breaker that way. One of the last demos I want to show you is one of the other requests we get frequently is for some kind of request rate limiting. So rate limiting algorithms are fairly well known, but they're hard to implement in a distributed manner and to get it right, because you have to have some shared state somewhere, right? So user X, he only has 100 API requests a minute, and if you have so many gateway servers, you need to keep track of how many he's requested on A and B and C, right? So Stripe wrote a great blog post about what they did and how they used Redis. Redis is one of the things that's available on Cloud Foundry that we support, and so it was natural for me to use that. And so that's what this is built upon. So if I create a route that we're going to call limited, again, I'm a lazy programmer, copy and paste, right? Limited.org, except I need a different filter here. So this filter is a little different because it's a bean and it needs some other things injected to it. So we're going to add that as a parameter to our command, and then we're going to build the factory. And I'm only going to say you get 1 request a second. But that needs a particular key, right? So it needs to decide who you are, right? Whether that's an API key, a user login, whatever it is, cookie, whatever it is, you can write a, it's called a, oh, wrong parameter here. It is a key resolver. So I'm going to go ahead and write just a simple one that takes a, let's see, we need to create a mono, and it's going to just use the exchange, get request, get query parameters. I'm just going to use a query parameter. Normally I would plug in Spring Security, but I didn't want to deal with that in the demo. So we're going to get the first ID query parameter, okay? And we'll go ahead and again route it to HTTP bin. That's not the last demo, so I want to hurry and get this one done. So it's limited to tests to 1 second, and I can't do that fast enough in my shell, so I have a test kind of already written here. I need to plug in the port, local server port. So this test says, for 20 times, I'm just going to make this call, right? I'm using Spring's web test client, and I add the host parameter, which matches the predicate that I'm matching. And again, all I need here is an ID parameter. So when I run this, it's going to, I expect it to fail with a failure that I don't have any more tokens available, right? So we'll go ahead and run this test. Oh, I ran the application, not the test. Oh, I know what There's no port because it wasn't running a port. So it failed with an HTTP code of 429, which is a standard code that says you don't have any more requests, right? So the one last demo, if I can do this quickly, is to show you WebSocket support. So we're going to route WebSockets. Well, this is one of the main reasons that we built this, is because Zool doesn't handle long-lived connections like WebSockets. So we just change this to the WebSocket protocol, localhost 9000. Now you're saying, what's on localhost 9000? We're going to split this. I can show you what's running. It's a little tool that just spins up a simple WebSocket server. It's waiting for connections. And just to prove that we're not going directly to the server, we're going to be going to 8080, which is our gateway, right? So WebSocket client connects to gateway, gateway connects to WebSocket server. It's a man in the middle, right? Let's see, make sure the application is actually running. And I can run my client. You can see it connected. Now if I send something from the client, the server received it, but I can send information from the server back through the gateway to the client. Ta-da! So we have WebSocket support in the gateway. And it was fairly easy because Spring Framework has fantastic WebSocket support. And I was able to just plug it in. I didn't have to write WebSocket clients and know all about all the protocols ins and outs. It was just, I could reuse it. And with that, I'm done. We have 30 seconds for a question. It's got a mic coming to you.
Do you plan to provide any support for HTTP 2 and gRPC?
Plans to support HTTP 2 and gRPC. So HTTP 2 support will come from Spring Framework. So yes, we do have plans to support HTTP 2. Currently, it's only supported if you use Tomcat, Jetty, or Undertow, because Reactor's Netty support doesn't have HTTP 2 support yet, but that will come. But yes, we do. gRPC, I have an open issue. I'd like to, but probably not for the first version that we release. It'll probably come after that.
Okay, thanks.
Thank and we're out of time. You can come ask me questions after. Thanks for listening.